This is the video presentation for Engineering Economy, the code VDA 40902. Our title is Assignment 1, Application of Engineering Economy Concepts on Initializing New Business Proposal. Our daughter is Dr. Nasuha. And our group members is formed out by 5 members. That is me and Junjin. And the second is Anderson Tinkai, Kelvin Lim Timfong, Ahmad Zufadli Yusri bin Ghazali, and Amza Shawa bin Hasana Shari.
Hello, good morning. My name is Kelvin Lim. My number is CD210131. Now I will present about the introduction. Engineering economy is also a streamlined application of microeconomic theory. Scientists consider factors like price setting, rivalry, and demand or supply to be constant input from outside sources. Additionally, it shares a lot of similarity with other disciplines like statistics, mathematics, and cost accounting. The analytical strength of mathematics and statistics are added to the logical framework of economy. Fundamentally, engineering economy is formulating, calculating, and assessing economy result in the presence of alternatives that can achieve a specific goal. After that, in this assignment, the cost or profit analysis will be carried out. The cost and profit analysis is one of the methods of cost accounting. Cost or profit analysis consider the impact on the operating profit due to the varying level of volume and the cost. Then it is also used to determine a break-even point for cost structure with different sales volume, which will help manager in making economic decisions for short term. Engineering economy is a branch of economics dedicated to studying how economic principles can be used to analyze this engineering decision. Its focus is on the area of microeconomics, which look at how people and business behave when deciding how to divide out scarce resources. As a result, it emphasizes decision making as well as its context and environment. Its pragmatic nature integrate engineering experience with engineering economic theory. SGD 17. The Sustainable Development Goals are a set of global goals that the UN created in 2015. One of the goals is to strengthen the means of information and re-energize the global partnership for sustainable development. This goal is aimed at improving international relationship between developed and developing countries and creating a global trading system that is fair, open, and advantageous to all. To achieve this, the SGD call for coordinated investment activity and encouragement of international commerce. Now I will present about the description and justification of the product selected. We have chosen electric car as our product. This is a summary of what electric car is, what advantage they have over traditional vehicle, and how they are becoming more popular. Electrical vehicles are pollution-free and also environmentally friendly thanks to their use of lithium battery. Various electric car parts make the electric vehicle efficient to run on the road, and many drag racer electric vehicle features straightforward two-speed manual transmission to increase top speed. The electric car was chosen because it is related to the Sustainable Development Goal 7, ensuring access to affordable, reliable, sustainable, and modern energy for all. Most of the battery of the electric car can be reused, but the recycling process is complicated and must be done by trained professionals. Usually, the battery of the electric car are lithium cell. The recycling process of the battery of an electric car can be done by breaking down the cell into their parts. The recycling process starts by removing combustible materials such as plastic and insulation, and the cells are then chopped into small pieces and heated until the metal liquefies. The metal is then poured into mold to create new cells. In short, the battery of the electric car can be reused and recycled. Then, instead of using fossil fuel like gasoline or diesel to charge the battery, electric vehicles use electricity due to their greater efficiency and the lower cost of power. Charging an electric car is more affordable than purchasing gasoline or diesel for the travel need. With significant fewer moving components, electric car never need oil changes, no spark plug, or fuel filter. By using the electric motor to slow down the car, regenerative braking also increases the life of brake pad. Usually, this results in reduced maintenance expense overall and more saving. Hence, the electric car that use electricity reduce the use of petrol or diesel in more affordable, reliable, and sustainable way. In addition, the electric car also related to SGD 13, take urgent action to combat climate change and its impact, as the electric car use electricity as oil. Hence, the electric car is enabled to improve the air quality in town and city, including a large reduction in local air pollution. Due to the electric car do not have the exhaust pipes, it do not emit the carbon dioxide gases when driving as compared to the internal combustion engine automobile. The carbon dioxide, also known as greenhouse gas emitted by the ICE automobile, always damage the ozone layer of the earth, and it will cause the global warming. Therefore, the electric car that uses electricity as the fuel produces less carbon emission when compared to an ICE vehicle that uses petrol or diesel, and is better for the environment as they emit fewer greenhouse gases and air pollution to the environment.
Second part, Business Proposal. 2.1, Description and Justification of the product or part or the service selected. The product that our group has chosen for research is electric vehicle, or also known as the electric car. So the electric car uses a battery. It is pollution-free and almost environmentally friendly. The electric vehicle emit fewer pollution overall, no exhaust emissions, and are quieter than cars with internal combustion engines, or we also known as the ICE vehicles. So the electric car have a lower overall cost of ownership than that of the ICE vehicles in the United States and the European Union due to the lower fuel and maintenance expenses. The electric car was chosen because it is related to the SDG 7 that is ensure access to affordable, reliable, sustainable and modern energy for all. Most of the battery of the electric car can be reused, but the recycle process is complicated and must be done by trained professionals. So usually the batteries of the electric cars are the lithium-ion cells. The recycling process for the batteries of an electric car can be done by breaking cells down into their parts. Instead of using fossil fuels like the gasoline or the diesel to charge their batteries, the electric vehicles use electricity to charge their battery. Due to their greater efficiency and the lower cost of the power, charging an electric car is more affordable than purchasing the gasoline or diesel for the travel needs. In short, the electric car that uses electricity reduces the usage of petrol or diesel is more affordable, reliable and sustainable. For the second part, the electric car also related to the SDG 13. There is take urgent action to combat climate changes and its impact as the electric car uses electricity as the fuel. So the electric car is enabled to improve the air quality in towns and cities, including a large reduction in local air pollution. Due to the electric car do not have the exhaust pipe, it do not emit the carbon dioxide gases to the environment when driving as compared to the internal combustion engines automobiles, that is the ICE vehicles. The carbon dioxide, also known as the greenhouse gases that emitted by the ICE vehicles, always diminish the ozone layer of the earth and it will cause the global warming. Therefore, the electric car that uses electricity as a fuel produces less carbon emission when compared to the ICE vehicle that uses petrol or gasoline or the diesel, and it is better for the environment as they emit fewer greenhouse gases and air pollutants to the environment. 2.2. Identification of material requirement and manufacturing process involved. We also include the estimation of cycle time for each process. So the figure 3 shows the components of the electric car. It consists of the battery, charger, fuel storage, light wedging materials, power electronics, electric motor, engine and the radiator. For the first component is the battery. The materials used to make the battery is lithium, cobalt, manganese, nickel, graphite and other metals and materials. So in the manufacturing process, we will make the battery cells first, then we will use the battery cells to produce the battery modules, and finally we have the battery pack. So the process to manufacturing the battery of electric car is fabrication process by using the battery cells as the raw material in the battery pack. So the cycle time for all of the manufacture the battery is 2 hours. For the second one is interior of electric vehicle. So the interior of electric vehicle may made up of the leader, the wing and forks, the fabric. So the manufacturing process involved is the molding process. Then the cycle time to manufacture the interior of electric vehicle is 18 months. The third one is the exterior, that is the body kit of an electric car. So material to make up the exterior is usually the aluminium. So the sheet metal parts of the car body are created and stamped by robots, and this part form side frames, doors, hoods and roof, and later add onto the main frame of the car. Once the frame is created, the parts are ready to be assembled and the car will be loaded onto a production line, and the car will travel along a moving assembly line in factory as robots and people work on them. So the cycle time is the 6 hours for the exterior, that is the body kit of an electric car. For the electronics and electric system, that consists of the battery pack, power inverter, electric motor, onboard battery charger, battery management system, charging port, thermal system, controller. The material involved is the fuse, relay, battery, alternator, starter and motor. So the primary process used to manufacture these electronics include the design and assembly of printed circuit boards or PCBs, cable assembly, packaging, prototyping and testing. The cycle time is 4 months. And for the drive is usually the components and system that convert the electricity power in the drive system of the electric vehicle. The material involved is fuel cells, batteries or other power source depending on the context. The process include in e-drive and glass container manufacturing, clamping and positioning, converging and sorting process. And the cycle time is 5 hours. Then we have the assembly part. So the material to use in the assembly is the automated robot arm. So for car assembly, these are the various workstations to install parts of the car in sequence. The concept of assembly line is to speed up the manufacturing process as well as increase the efficiency and overall resulting output, and the idea is not exclusive to automotive industry as various manufacturing industry have adapted the concept of assembly. So the cycle time is 17 to 18 hours. For the chassis, the material used is the carbon steel and aluminum alloys. The chassis has to accommodate various systems such as frame, wheels, brakes, steering and the suspension. So in order to maintain the rigidity of the wall structure, the solution creates Third, from expertise and modern engineering capabilities are needed in the manufacturing of a chassis. In addition, supplementary processes such as the fabrication and the machining work for our customer so that the final product can be delivered under a single pusher order to a single supplier. The cycle time in the chassis is 36 hours. For the powertrain drivetrain system, the definition of the powertrain is an assembly of every component of pushes vehicle forward. The car's powertrain grabs the power from the engine and drives it to the wheels on the ground. So the material used is a set of planetary gears that reduce motor speed to the appropriate speed and torque that are needed to drive the wheels. So the materials usually are the cast iron, aluminum or steel. So the manufacturing process for the planetary gears is the internal gear teeth cutting process by using the sorting machine, and the cycle time is 20 weeks. So after the 8 main components of the electric car is manufactured, these parts will be assembled together by the machines and the train workers. The robotic work cells will walk along the wheel, solder, screw and glue parts onto the car. All the battery chassis, e-drive system, electronics and electrical system, powertrain or the drivetrain system, as we mentioned just now, will be installed into the electric car, and the tires are furnished so that the car can stand on its own. 2.3. The identification and procurement of machining involved. The machinery involved to manufacturing the electric car is the conveyor belt, welding robot, painting robot, beam transport robot, overhead conveyor, CNC machine, jig welder, cell winders machine, tape welders machine, air wrench, spot welder. So for the procurement of machinery involved, first we can direct order from the manufacturer. Second, we can renting and leasing the machinery involved to produce the electric car. And the last one is order from the manufacturer's representative.
Assalamualaikum, my name is Ahmad Fadli Yusri bin Ghazali. My matrix number is DD200009. I am student from FKMP. So now I would like to talk about the determination of machine ownership, operational and maintenance cost. So first, machine ownership cost. Machine ownership cost is the cost of to buy the machine. So first, conveyor belt 22,100 ringgit, welding robot 66,100, painting robot 66,100, beam transport robot 70,000, overhead conveyor 9,800, SIC machine 100,000, jig welder 53,000, cell winder machine 26,000, tape welder machine 10,000 ringgit, air wrench 3,000 ringgit, spot welder 13,000 ringgit. So the total for machine ownership cost is 439,100 ringgit. For the second, operational cost. Operational cost is the cost to operate the machine, which is electric cost. First, conveyor belt 120 per hour, welding robot 100 per hour, painting robot 100 per hour, beam transport robot 100 per hour, overhead conveyor 120 per hour, CNC machine 100 per hour, jig welder 20 per hour, cell winder machine 20 ringgit per hour, tape welder machine 20 per hour, air wrench 10 per hour, spot welder machine 10 per hour. So the total is 730 and 30 ringgit per hour. For the third, maintenance cost, which is the cost for maintain the machine, which is conveyor belt 200 per month, welding robot 200 per month, painting robot 200 per month, beam transport robot 200 per month, overhead conveyor 200 per month, CNC machine 200 per month, jig welder 50 ringgit per month, cell winder machine 100 per month, tape welder machine 50 ringgit per month, air wrench 10 ringgit per month, spot welder 50 ringgit per month. So the total is 1,460 per month.
For the part 3, product cost and profit analysis. 3.1, the estimation of total cost per unit. The cost per unit of an electric car can be determined by the formula below. The cost per unit is equal to the sum of the total fixed cost plus the total variable cost divided by the total number of the units produced. Therefore, from the section 2.2, there are 8 main components that is the materials to manufacture the electric car. This materials is also known as the variable cost, VC, and the cost of each materials of the electric car is shown in the table below. So in the first component is the battery production cost by 35,200 ringgit. For the cost of the interior, it is 11,900 ringgit. For the exterior painted in white, it is 9,250 ringgit. For the electronic and electrical system, it is 8,800 ringgit, and the e-drive also have the same price as the electronic and the electrical system. The cost of the assembly is 8,600 ringgit. Manufacturing of the chassis is 5,720 ringgit, and the powertrain or the drivetrain system is 3,080 ringgit. So the total cost will be 89,350 ringgit per electric car. Then the fixed cost can be obtained from the machine ownership cost, operation and maintenance from section 2.4. The average electric car manufacturer is 7,000 cars per week, which also equal to 1,000 cars per day. And this is from the source of electric.com downloaded from the website. Hence, for 1 month, that is 30 days, the estimation of 30,000 electric cars can be manufactured. Therefore, the total cost of fixed cost FC equal to machine ownership cost per month plus the machine operation cost per month plus the machine maintenance cost per month, and we will have a value of 160 ringgit per month. For the total cost of variable cost VC, it is equal to the materials cost of each car times the electric cars manufacturer per month, and we will have the 2.6805 billion per month. So the cost per unit will be the total fixed cost plus the total variable cost divided by the total number of units produced, as I mentioned just now. So we will have the value of 89,382.21 ringgits per electric car produced.
Okay, my name is Amdul Shawal. Okay, my part is determine of sale price, break even, and profit margin. Okay, about sale price, the sale price of an electric can be determined by adding the cost, insurance, service, tire, everything charge, and each solid unit. Every dealership make up per unit, everything sales tax for each car. So according the ready to go source, we can see material 89, 350, insurance, service, tire, every estimate, and total is 131,855. And we go to break even. Break even is formula fixed cost divided by sale per unit minus variation cost per unit. So our break even point is 966 divided by 131,855 minus 89,350, and total is 32 ringgit 70 cent. And we go to profit margin. Profit margin is formula total sale minus cost of sale divided by total sale multiplied by 100. So our gross profit percentage is 131,855 minus 89,382 divided by 131,855 multiplied by 100, and we get 32.31%. Based on the calculation, we can conclude that company profit margin is 32.21%. This means that the generation of RM 0.3221 of profit margin for every sale, 1 ringgit for sale. Therefore, an electric car, the profit per electric car sale price of electric car at multiplied by 32.1%. So our profit 131,855 multiplied by 32.21%. So we get 42,470.50 cents per unit car. For the sale car and electric car, which equal 131,855. The profit 42,450 cents can be obtained by selling the electric car. Thank you.
Part 4. Conclusion. In other words, we can determine the variable cost VC of electric car, which equal to 89,350 ringgits by adding up all of the 8 components that used to manufacturing the electric car. Besides, the total fixed cost FC, which equal to 966,160 ringgits per month, can be determined by the sum of machine ownership cost, machine operational cost, and machine maintenance cost. Then the cost per unit of electric car is 89,382.21 ringgits, while the total sales of an electric car is 131,855 ringgit. In addition, our company will gain the break-even of 22.73 ringgits and attempt a profit with the gross profit margin up to 32.21%, which means that the electric car generates 0.3221 ringgits of profit for every 1 ringgit of sales. Therefore, for the sale price of electric car, which equal to 131,855 ringgits, the profit of 42,470.50 ringgits can be obtained by selling an electric car. In conclusion, the company will gain the profit of 42,470.50 ringgits when each of the electric car is sold.